What if we surpassed the speed of light before the end of the decade? Mankind enjoys breaking records, but have you ever wondered what would happen if we managed to surpass the greatest record in human history? Today, let's examine the implications of achieving the speed of light by the end of the decade. I believe that humans are inherently competitive. Just take a look at our past. We have engaged in conflicts for both hegemony and territory. Sports and the Olympics were developed. We have created games that are competitive. We even have eating competitions. As if those weren't cutthroat enough, these examples demonstrate how our ability to demonstrate our superiority over other beings is ingrained in our DNA and contributes to the betterment of our own species on many levels. Now, combining that with our curiosity, see what I did there, we have arrived at one of humanity's most ambitious projects in recent memory, exceeding the speed of light, the universe's highest speed cap. Whatever the primary motivation, the desire to travel at the speed of light has long been a staple of fiction writing. From the Millennium Falcon's leap into hyperdrive in Star Wars to DC's beloved speedsters in the Flash universe, authors all across the world undoubtedly share this desire. So what makes achieving this degree of speed so special? Let's go a step farther with that. If we manage to surpass the speed of light before the end of the decade, what makes it so special? Do we finally have a cancer cure? Do we eventually establish peace on Earth and put an end to all wars? Does global warming suddenly come to an end? We're not really sure, but who knows? It's possible that we'll solve them all if we learn how to travel at the speed of light thanks to our creativity. The most obvious response is that since we move more quickly, we can travel further into the cosmos. We will learn and finally comprehend more about the universe the further we can travel. Let's begin with a well-known example to provide some context, something that happens every day, as the sun shining on Earth. It's likely that you already know that light takes more or less 8 minutes to reach our planet if you paid attention in elementary astronomy class or to any other science lectures available. And it's a difficult distance to travel. The Sun and Earth are typically located at a distance of around 149 million kilometers. Imagine the adventure that would ensue if the Thrust SSC, the fastest land vehicle in the world, were sent on a single journey to our own star. Let's simply pretend it's possible. It would take 14 years to travel there, or 28 years to return, even at its supersonic speed of 1,228 kilometers per hour. A child could be born on the day it takes off and grow up to be an adult office worker by the time it returns. But if you were moving at the speed of light, you could probably do it once you see that movie. Think about how absurd that is for a moment. Recall the recent Mars rovers that touched down there in February? If they were traveling at the speed of light, their voyage would have only taken a little over 3 minutes instead of almost a year. That will speed up many of our planned missions to Mars as well, and the technological advancement required for our objective to conquer the Red Planet will accelerate tremendously. Our colonies may start to take shape as soon as next year. We may seem to be suffering extreme FOMO about discovering the universe, but the truth is that we actually have a finite amount of time to learn everything there is to know. Hubble, one of our greatest astronomical heroes, made it possible to prove that the cosmos had been expanding continuously. It's simple to imagine us simply waiting for the time when technology would allow us to interact with distant objects in our universe. We humans are, after all, quite creative creatures. It shouldn't be too long before this kind of technology is developed, right? That may be the case, but the cosmos is expanding at a rate that is much faster than the speed of light. Recall how general relativity by Einstein demonstrated that time and space are basically two sides of the same sheet and that everything passes through this? Hence, for lack of a better description, it only seems reasonable that the material should expand more rapidly than everything on it. Having said that, if we don't rapidly explore the cosmos, eventually nothing will be visible since it will be so far away that there won't even be any stars or planets. The other things in our universe would be so far away from us in terms of magnitudes that we would be forced to think that we were the sole planet in the universe. That is, of course, if our society survives until that time. What else occurs when we surpass the speed of light, then? This next item will undoubtedly be intriguing for you if you're a fan of wellness and maintaining your young. If we manage to surpass the speed of light by the end of the decade, we'll also be able to significantly slow down the aging process. Before we do that, I'd like to hear from you people. How do you like the show so far? Post a comment below and let us know. At this point, just because we attained the speed of light and established contact with some eternal businessmen selling cosmetics, we won't uncover any cosmic facial cream or some divine serum that we can inject. All we're going to need is some beautiful old astrophysics, not biology and chemistry. According to Einstein's special relativity, the cosmos can move at a maximum speed that produces bizarre phenomena. In particular, if you manage to run this quickly, time slows down for you as your length reduces, your mass near infinity, and your speed increases. Now, I want you to pay attention to that last part. Remember how we said that when the speed of light was established as the upper limit for the cosmos, the paradigm of time as the ultimate norm for everything in the universe was replaced with a new one? This connects to that. It may surprise you to learn that this has previously been shown, or rather imagined, in a thought experiment known as the twin paradox. Let's say John and Johnny are identical twins. Johnny decides to pursue a career as an astronaut and launches into space for a mission that will last roughly 20 years, measured in Earth time. Naturally, we don't anticipate Johnny to be traveling on a slow-moving rocket. The rocket will travel at a speed that is less than a fraction of the speed of light. Maintaining thus far? Let's imagine that after 20 years, Johnny returns home after finishing his assignment. The twins should appear entirely different from one another if Einstein's theory of special relativity is accurate. Although Johnny remained on Earth, John experienced the effects of time passing. Johnny also aged somewhat, but not as much as John. Although sharing many of Johnny's facial features, John appears to be a much older brother. NASA carried out a slightly related investigation on the astronaut twins Mark and Scott Kelly back in 2015. It was a great opportunity because, how frequently do twins choose the same major and employer during their lifetimes? NASA would be insane to pass up this fantastic opportunity. The investigation so proceeded just as you would have predicted. As the other twin spent time in space, the other was abandoned here on Earth. Scott had the good fortune to serve as the experiment's guinea pig while Mark was in charge of mission control. The objective of this experiment, however, was to learn more about the impacts of a human body spending a complete year in space, not only to ascertain whether or not you may genuinely age slower in space. Studies revealed that Scott's physiological and psychological makeup had changed significantly when he returned to Earth, but everything had returned to normal after a few months. Age-wise, it was discovered that Scott's aging actually slowed down while he was in space, despite being exposed to extreme stress, radiation, and effects of the absence of microgravity. However, if you were to ask me, I would reply that a year is just too brief to identify any and all substantial consequences that space travel might have on a human, if we could develop the means to travel at the speed of light. The phrase was essentially Dory's mantra from Finding Dory, just keep swimming. We must be on the move all the time if we want to maintain our young. Isn't it lovely how in a new setting that makes perfect sense in our lives? Well, so all of these fantastic characteristics appear to be attainable after we surpass the speed of light. The next thought that probably crosses everyone's mind right now is, how can we complete this mission as quickly as possible? Is there a practical method to accomplish this? The unfortunate part about this is that we are specifically prohibited from going faster than superluminal speed by the rules of physics. There is yet hope though. Particles can already be accelerated to approximately 99.9999991% of the speed of light thanks to technology. Nearly every day, particles are accelerated in the Large Hadron Collider at CERN to as close to the cosmic speed limit as they are capable of traveling. To gain a glimpse of the basic elements that comprise everything in the universe is the aim of this. Would you be interested in finding out more about this? Please tell us in the comment box below, and I'll finish that video right away. In general, it is simple to understand theoretically how LHC completes this work. In essence, the collider is a large oval with several magnets within. The magnets are controlled by the scientists, who alternately switch them on and off very quickly so that the particle accelerates beyond the speed of light until it is just a few decimal places away from it. Now, for particles, this took a very long time to develop. You may ask what happens if we increase the scale to something we can use for space travel. There are many more problems that arise with attempting to create anything so monumental, but in its roughly 200,000-year history, mankind has accomplished many amazing things, right? Who can predict what the future may bring? Maybe one of the amazing people that watch this show will finally give it a shot and get it flying. The process of solving the universe's riddles is a protracted and difficult one, and time shouldn't be a major concern if our goal is to spread knowledge. What about you guys? What strategies do you propose for achieving the speed of light? Please share your thoughts in the comments box below.